Assalamualaikum warahmatullahi wabarakatuh. We are Group 6 from KTSP3. We'll be presenting about Haloalkane for course code TST0925 Physical and Organic Chemistry assignment. So let's get started. Let's get to know us. So this is the team. The one speaking right now is me, Shasha Nabiha, and my teammates are Nur Amirah, the twins, Nureen Syazwana and Nureen Syazwani, and the last one is Wardina Fatihah.
Introduction to Haloalkane.
What is haloalkane? The haloalkanes, also known as alkyl halides, are a group of chemical compounds comprised of an alkane with one or more hydrogens replaced by a halogen atom, which are fluorine, chlorine, bromine, or iodine.
Solutions for problems regarding the synthesis and reaction of haloalkane.
This haloalkane is a bromopropane. This bromopropane will react with KCN and alcohol in reflux, and then the cyanopropane will be formed. So this bromopropane is classified as primary halide. Next, the type of mechanism. It is biomolecular nucleophilic substitution reaction, or we call as SN2. So the most important thing that we must know about SN2 is it must be drawn in 3D structure. So here it is. The Cn negative ion will attack to this carbon from behind and undergo slow reaction. The transition state then will be occur in negative charge. And then this one will undergo again fast reaction and cyanopropane will be formed. So this is how the cyanopropane can be formed from bromopropane.
And here is our answer. From the question, we need to synthesize amine by using reduction and carboxylic acid by undergo hydrolysis. Okay, first, compound B, which is cyanopropane, will undergo reduction process. As you can see here, the nitrile compounds will undergo nucleophilic substitution to form primary amine. So it will react with hydrogen with platinum catalyst under heat condition. But for the information, we could also use other reagents such as ether and H3O+. And for the catalyst, we can also use either platinum, palladium, and nickel. But as you can see here, I choose to use platinum for this reaction. And then the last product will form, which is butanamine. Second, that's for the hydrolysis process. The nitrile compound will give carboxylic acid as the product. The cyanopropane will react with H2O and H+. The Cn here, as you can see, it will be substituted with COOH, and then it will form butanoic acid.
The first step for the synthesis of 2-methyl-3-hexanol from 2-bromopropane is to do the Wurtz reaction. In this reaction, bromobutane will react with the isomer C, which is 2-bromopropane, and sodium in ether solvent to produce 2-methylhexane and bromine. The second step is the halogenation reaction, which is the free radical substitution. In this reaction, 2-methylhexane will react with bromine in the presence of sunlight or UV to produce 3-bromo-2-methylhexane. And the last step is the nucleophilic substitution with potassium hydroxide KOH. In this reaction, 3-bromo-2-methylhexane will undergo hydrolysis with aqueous potassium hydroxide under the condition of reflux to produce 2-methyl-3-hexanol, which is the last product. The next one is the synthesis of benzene 1,4-dicarboxylic acid from 2-bromopropane. So the first step is to do the Friedel-Crafts alkylation. So in this reaction, benzene will react with the isomer C, which is 2-bromopropane, in the presence of Lewis acid as a catalyst. So right here, the Lewis acid used is ion 3 bromide to produce isopropylbenzene. The second step is also Friedel-Crafts alkylation, whereby isopropylbenzene will react with 2-chloropropane in the presence of aluminum chloride to produce 1,4-diisopropylbenzene. first step is the oxidation reaction of alkyl benzene. In this reaction, 1,4-diisopropylbenzene will react with potassium permanganate, H+, and in the presence of heat to produce benzene 1,4-dicarboxylic acid, which is the last product.
Moving on to the next part of the presentation, which is the integration of nucleic and alkylic component on the chosen plant mentioned in the Quran that has haloalkane as one of its active compounds. The plant chosen is Salvadora persica. It is widely known as toothbrush tree or miswak that has been used as a natural toothbrush for decades. The fibrous branches of this plant have been recommended by the World Health Organization to keep your oral hygiene in check. The active component found in this plant is dichloromethyl. It is a haloalkane substituent in this long compound here. It is a chemical compound found in the leaf extract of a Salvadora persica. The percentage of area covered by this active component is 4.07%. The diagram at the right here shows the structure of dichloromethyl in skeletal form, and its IUPAC name is dichloromethane. The Salvadora herb is related to one of the ayat in Quran, which the tafsir goes as, "So call upon your Lord to bring forth for us from the earth its green herbs and its cucumbers and its garlic and its lentils and its onions." Moses said, "Would you exchange what is better for what is less?" This ayat from Al-Baqarah ayat 61 is telling about a story of Bani Israel who's impatient and bored with just one type of food available for them, and that they said to Moses to ask from Allah to bring out from the earth much more harvest, much more plants like green herbs, onions and garlic, because they wanted to live in varieties and prosper on this world. So the green herbs mentioned here also include Salvadora persica, where it can be eaten as part of salads and also used in traditional medicine. Clearly, it has numbers of health benefits to human beings. Next is the composition of the plant, where Salvadora persica seeds contain 30 to 40% non-edible oil with over 50% lauric and myristic acids and few C and acetic fatty acids, making it a viable alternative to palm oil in the soap and detergent industry. Next is the leaves that have high water content, which is 15 to 36%, making them a valuable water supply for animals like camels who have a high water recycling capability. The bushes of Salvadora persica are low in cuprum, zinc, and manganese, but contain disproportionate quantities of manganese, selenium, and sulfur. Its high concentration of sodium chloride, which gives it the name of salt bush, makes it a real salt remedy for livestock and gives it the taste of milk. Salvadora persica fruit is also regarded as the natural source of antioxidants, essential amino acids, mineral nutrients, proteins, and other metabolites.
Benefits of the plant.
Here are several health benefits of the plant. Firstly, this plant has antibacterial effect. Miswak includes gallic acid, sulfur, salvadorine, and trimethylamine, both of which have antibacterial and antimicrobial properties, and therefore help in the inhibition of bacterial development. Miswak's antimicrobial properties can also be used to disinfect your tongue as well as your teeth. Secondly, this plant could reduce cholesterol. According to animal research, a stem decoction of Salvadora persica could lower cholesterol and LDL plasma levels in rats. Next, it could reduce gastric ulcers. Animal tests indicate that Salvadora persica has a beneficial role against alcohol and stress-induced gastric ulcers. Fourth, Salvadora persica has antifungal activity. Candida is to blame for a variety of oral cavity infections, and miswak extracts has been shown to be useful in the treatment of this fungal infection. Salvadora persica could also reduce gingivitis. According to research, miswak has a positive impact on a dental plaque and gingival inflammation level. Miswak extracts have the ability to prevent the growth of numerous bacteria that are essential for plaque formation. And lastly, I can say that health benefits of this plant is it acts as anti-cancer properties. Finally, the end. Thank you for your attentive listening and attention.